So students, here we are discussing section A part of ISC Board 2025. Question number 1 and all the parts of question number 1 we have already discussed in our previous video. You can watch that video. So let's start from the question number 2 here. The question is, find the point on the curve y is equal to this at which the tangent is parallel to the x-axis. As we know, any tangent which is parallel to the x-axis, its slope equals to 0. Always remember this. And any tangent which is perpendicular or parallel to the y-axis, if parallel to the y-axis, then we will considering its slope as 1 by 0. So these are the basic concept which you have to remember all the time while solving such type of problem. So let's start here. First, what we have to do, we have to find the dy by dx here. So here y dash is equal to 4x minus 6 only. So y dash is the slope of this curve, that means the slope of the tangent, which is 4x minus 6. Now it is saying that this tangent, that means the slope of this particular tangent is parallel to the x-axis. That means this is equal to 0. As we have discussed, the slope is equal to 0 when it is parallel to the x-axis. So from here we can easily find the value of x, that is 3 by 2 only. So this is the value of x is equal to 3 by 2. Now we have to find the point on the curve. So here we have already find the coordinate of x. Now we can easily substitute this value of x in the given equation to get the value of y. Very simple. So here we can easily find y is equal to 2 into 3 by 2 whole square minus 6 into 3 by 2 minus 4. By solving this, we can easily get the value of y here. So let's erase it so that we can solve it here. So here we can see that y equals to what? Y equals to 2 into 9 by 4 minus 6 into 3 by 2 minus 4. So we can easily cancel this out. So we will get what? 9 by 2 minus 9 minus 4. So this is equal to 9 by 2 minus 13. If we take the LCM, then we will get 9 minus 26 by 2, which is equal to what? 17. 17 plus 9, that is negative of 17 by 2. So we will get minus 17 by 2 is the value of y coordinate here. Very simple question it was, and we can easily solve such type of question within 2 to 3 minutes, not more than that. So we can say that the coordinate are 3 by 2, or we can say point is 3 by 2 and minus 17 by 2. I hope the concept is clear now. Now let's move towards question number 3. Now let's move towards our question number 3, students, and this is our question number 3, where it states that we need to find out this one, that is tan inverse x minus cot inverse x we need to find out. And when it is given that tan inverse x whole square minus this equal to 5 pi by 8. So in such conditions, in such a scenario, or in such a question, what we have to use, we have to simply use this property, tan inverse x plus cot inverse x equals to pi by 2. So what we have to do, basically what we have to do is we have to convert this equation in a single inverse trigo function. That means with the help of this we can simply convert cot inverse x in tan inverse first, and also we have to substitute. Let us assume that tan inverse x equals to t, so that we will not get confused with lot of variables here, with lot of trigo equations or trigo functions here. With the help of t we can easily find out the quadratic equation in terms of t. So what we can write down like this, tan inverse x is t, so we'll get t square minus this part will become pi by 2 minus t whole square. Very simple, and equals to 5 pi by 8. What we have to do now, we have to simplify it so that we can find out in terms of t this equation. So this implies t square minus, we can simply expand it by using a minus b whole square, pi square by 4 minus 2 pi by 2 into t and plus t square, very simple, equals to 5 pi by 8. Now we can see that after expanding it, t square is getting cancelled, and we have to take care, because if we open the bracket then all the sign will change here. Now we will get minus pi square by 4, and this is going to get cancelled, and we will get plus pi t or t pi equals to 5 pi by 8. Very simple. Now we can simply do one thing, that we have to take out the value of t in terms of some pi and some constant here. Now let's move forward, make some space here. So this implies what? Simply take the LCM here. We will get the complete LCM as 8 here. So this implies minus 2 pi square plus 8 pi t equals to 5 pi. Very simple. So this implies what? We can simply cancel out pi in each term here, and we can simply write it this way: 8t equals to 5 plus 2 pi here, and this implies t is equal to 5 plus 2 pi upon 8. So this, we are getting the value of t, and t was tan inverse x here. Now as per the question, what we have to do, basically we have to find out the value of tan inverse x minus cot inverse x here. So simply we can substitute these values here in this question. So this is equal to tan inverse x is nothing but t, and t minus cot inverse x was what? Pi by 2 minus t. So this is equals to t plus t, that is 2t minus pi by 2. We will get 2t minus pi by 2 here. Now simply substituting the value of t as 5 or 2 pi plus 5 by 8 here. So we will get 2 into 2 pi plus 5 upon 8 and minus pi by 2. Very simple. Let's make some space here to solve it further. So here we will get what? We are going to cancel this. So we will get 2 pi plus 5 upon 4 minus pi by 2 here. We can simply take out the LCM. 2 pi plus 5 minus 2 pi here, which is, we are getting correct, 2 pi plus 5, and this is 2 pi. So we are getting pi, 2 pi cancel, and we are getting 5 by 4 here. So here we are getting the answer 5 by 4. So here we are getting 5 by 4. So this is our final answer for question number 3. Now let's move forward and discuss about question number 4 here. So students, this is the part 1 of question number 4, which states if this equal to this, then we have to prove that dy by dx equals to. This is very interesting question, and this is very important question as well. So now what we have to do here, it is stating fx whole raised to the power gx type function. Then in such a scenario, what we have to do, we have to apply logarithms. So here, by using log both sides, we are going to get log x raised to the power y is equal to log e raised to the power x minus y. This is basically y log x equals to x minus y log e, and we know that log e is nothing but 1 here. So what we will get here, we will get y log x equals to x minus y. So how we are going to tackle this question? This is little bit tricky question and very interesting question. Now what we have to do, we have to see this function. What we have to prove, basically we are having in the denominator 1 plus log x. So basically we need to get this factor somehow. So how we are going to do this? See, what we'll do, we will combine the y terms here. Y log x plus y equals to x here. Let's make some space here. So here we have y log x plus y is equal to x. Now taking y common, we will get 1 plus log x here, which is equal to x. Now what we'll do, we will separate x and y terms here. Very simple. 1 plus log x. Now if we see in the question here, what we need to prove? We need to prove 1 plus log x raised to the power 2 here. Now we are getting 1 plus log x here. Very simple. And we will be able to easily solve it out here. Now differentiating both sides by using quotient rule, we will get y dash is equal to 1 plus log x into x dash minus x into 1 plus log x derivative, 1 plus log x whole derivative upon 1 plus log x whole square here. Very simple. Now what we'll do, we'll simplify the given solution here. Now we will get 1 plus log x minus x into 1 by x, as the derivative of this is 1 by x and it is going to get cancelled here, and 1 get cancelled with this one. We will get log x upon 1 plus log x whole square. And what we need to prove, basically we need to prove this one, log x upon 1 plus log x whole square, and we are getting the same result here. So I think the concept is clear here. This was a very interesting question and little bit of tricky one as well. Now let's move towards the second part of question number 4. So this was the part 2 of question number 4, which states that fx equal to this, that we have to prove that fx attains its minimum value at x equal to 0. Simply we have to do f dash x first. So log 1 plus x derivative is what? 1 upon 1 plus x. Very simple. And the derivative of this is nothing but minus 1 upon 1 plus x whole square. So such type of derivative you have to remember, so that in the examination time it is going to save a lot of time of yours. So now what we can do, we can simply take out the LCM here. Now as we require the critical point here, so we are going to get f dash x, nothing but x upon 1 plus x whole square. So here we can see that 1 plus x whole square will remain positive always. So what we have to do, basically x equal to 0. So that means 0 is the critical point here. Now we have to test it. At 0 the function attains minimum or maximum value here. Now let's make some space here. So 0 is the critical point here. Now what we can do, we can simply make a number line. So from here, that is minus infinity to 0 and 0 to infinity, we can substitute any value from this part. Let us say we can put minus 1 here and see whether that f dash x is positive or not. So simply we will see that if we put negative here, it will remain positive and this will become negative. So from minus and from 0 to positive, 0 to infinity, if we put positive value, simply it will give us a positive value. From negative, the function behaves, f dash x is behaving from negative to positive. That means the function attains a minimum value here at x equal to 0. So function will attain a minimum value here. We have already proved that function, that is fx, attain its minimum value at x equal to 0. So that was the solution of part 2, question number 4. Now let's move towards our question number 5. So students, this is the question number 5, which was asked in the ISC Board 2025. 3 shopkeepers, Gaurav, Rizwan and Jacob, use carry bags made of polythene, hand paper and newspaper. The number of polythene bags, handmade bags and newspaper bags used by Gaurav, Rizwan and Jacob are this one. Simply, respectively, one polythene bag costs ₹1, handmade bag ₹5 and newspaper bag costs ₹2. Gaurav, Rizwan and Jacob spent ₹A, ₹B and ₹C respectively on these carry bags. Using the concept of matrices and determinant, answer the following question. Represent the above information in the matrix form here. This was a very simple question. Basically, we need to multiply the matrices which we are going to form, and there is no need to find the inverse in this question, as this question contains 2 marks only. So let's make a matrix X which is 20, 30 and 40, which was about Gaurav expenses. So 20, 30 and 40. Now let's move towards our Rizwan expenses, 30, 40, 20, 30, 40, 20, and Jacob spent 40, 20, 30, 40, 20 and 30. Simple. Now what it states? It states that one polythene bag costs ₹1, handmade bag ₹5, and newspaper bag costs ₹2 only. So y equals to, we can make a column matrix only. So 1, 5 and 2. Simple. So here we got our 2 matrices in the form of x and y, due to which we were able to solve the part 1 of this question. As it states, represent the above information in the matrix form. Now let's move towards our second part of this question, which states here that find the values of A, B and C here. So we need to find the values of A, B, C. And what is A, B, C here? A, B, C is the expense done by Gaurav, Rizwan and Jacob. So what we have to do? We have to simply multiply x and y, and we will get the value of ABC. So let's write it this way. ABC is equal to what? X into y. So let's make matrix 20, 30, 40. Simply we need to multiply and nothing else here. 40, 20, 30 into 1, 5 and 2. Very simple. So here we have this matrix we have written, and we need to simply multiply these matrix. Very simple. So let's do the product here. So first row, first column will give you first element. So 20 into 1 is 20, plus 30 into 5 is 150, plus 40 into 2 is 80. Now let's calculate for the second row. 30 into 1 is 30, plus 40 into 5 is 200, plus 20 into 2 is 40. Third row, 40 into 1, 40, plus 20 into 5, 100, plus 30 into 2 is 60. Now we got our product here. So let's add it and we will get the value of ABC. Very simple. 150, 150, 230, 230 and 20 is 250 here. 270, very simple. 160 and 40 is 200. So here we got our values ABC as 250, 270 and 200. We can simply write A is equal to 250, B equals to 270 and C equals to 200. Very simple. So in this manner we were able to solve both the parts of question number 5. Now students, let's move towards the question number 6, which was asked in the ISC Board 2025. So students, this is the question number 6 part 1 of ISC Board 2025, which states that we have to find the derivative of this. We need to find dy by dx here. So sine inverse 2 raised to the power x plus 1. This is a little tricky question, but interesting one. So what we need to understand first, that sine 2 theta equals to 2 tan theta upon 1 plus tan square theta. We need to apply this. So for such questions, we need to first simplify the inverse trigo part before proceeding further to get our derivative. So what we need to here, we need to do some sort of substitution here. We can simply write this part as 2 into 2 raised to the power x into 3 raised to the power x upon 1 plus 6 raised to the power 2x here, which is 36 raised to the power x. Very simple. So now what will be the advantage of this? We have to convert this part in this form so that we can simplify the inverse part here. So let's understand this. The numerator, we can write it this way: 6 raised to the power x upon 1 plus 6 raised to the power 2x. Now what we can do here, we can simply substitute 6 raised to the power x equals to tan theta. Very simple. So what we will get here is 2 tan theta upon 1 plus tan square theta. Very simple. Now we have simplified this part here. Now this means that this part equals to this part. Very simple. So we can write it this way: sine inverse of sine 2 theta, which is equal to 2 theta only. And what is theta here? Theta is nothing but tan inverse 6 raised to the power x from here. Theta equals to tan inverse 6 raised to the power x. Very simple here. Now we have to proceed further to get our derivative. Here we need to write y equals to what? Y equals to 2 tan inverse 6 raised to the power x, and y dash equals to what? 2 into derivative of tan inverse x is what? 2 into 1 upon 1 plus x square is nothing but 6 raised to the power x whole square into derivative of 6 raised to the power x, derivative of 6 raised to the power x here. Very simple. Now let's make some space so that we can further simplify it and find the value of y dash. We can write it this way: y dash or dy by dx equals to 2 into 1 upon 1 plus 6 raised to the power x whole square into a raised to the power x is what? We have to learn or remember this part. A raised to the power x is a raised to the power x into log a. That means the derivative of a raised to the power x is a raised to the power x into log a here. So we can simply write into 6 raised to the power x into log 6 here. So our answer is 2 log 6 into 6 raised to the power x upon 1 plus 6x whole square. So this is our answer here. So I hope this question solution is clear now. Let's move forward towards the second part of question number 6. So students, this is the second part, which is comparatively easier from the first part of question number 6. We have to show that tan inverse x plus this is equal to c is the general solution of the differential equation, this one. So what we need to do, we need to find the dy by dx and compare that whether we are getting this or not. Very simple question here. Now let's start with this. We need to find the derivative of this. Tan inverse x derivative is 1 upon 1 plus x square plus tan inverse y derivative is 1 upon 1 plus y square. With that we need to write dy by dx. Why? We are differentiating with respect to x here is equal to c derivative is 0. Very simple here. Now we can easily separate the dy by dx part and we will be getting 1 upon 1 plus x square is equal to minus of dy by dx into 1 upon 1 plus y square here. Very simple here. Now what we can do here, as per our question, we are having 1 plus y square dx. So here we can simply cross multiply here so that the dy part is with 1 plus x square and dx part will be with 1 plus y square. So we will get dx into 1 plus y square equals to minus of dy into 1 plus x square. This is very simple, and this implies what? This implies dy into 1 plus x square plus dx into 1 plus y square equals to 0, and this is our solution here. If we can compare this, what we have to prove here. So dy by dx into 1 plus y square and dx into 1 plus y square, and with the dy we are getting 1 plus x square, and hence proved. So this question, that is the part 2 of question number 6, was comparatively easier than the part 1 here. So I hope the concept is clear. Now let's move forward and solve the question number 7. So students, this is the question number 7 of ISC Board Mathematics Paper 2025. This question is also important question. So let's understand how to solve it with the help of properties here. Always remember that I will tell you how to solve such questions very easily. Whenever you see in a single row 1 1 1, you have to target this particular row and make any two elements 0. So how we can do that? We can simply use operation on C2 and C3. Let's do the first operation, which will be on C2, and we can simply write C2 minus C1, with the help of which we will be getting our determinant like this: 1x cube. Then here we are getting 0, y minus x, very simple, y cube minus x cube here. Now this is 1 z and z cube here. Now again what we can do, we can apply our operation on column number 3 here. What operation we can apply? C3 minus C1. So we will be getting our determinant like this: 1x cube, 0, y minus x cube, y cube minus x cube. This again 0, z minus x, z cube minus x cube. So I think the question is clear now till this point. So what we have to do, this is the easier method how to solve such determinant when one row is 1 1 1. We need to target that particular row and make any two elements equal to 0. Very simple. Now let's move forward. What we have to do, we need to take out, or we can do simply factorize the second column and the third column here. 1x cube by using a cube minus b cube here. So y minus x, a cube minus b cube is nothing but a minus b into a square plus b square plus ab here. Similarly, we can do factorize here: z minus x into z square plus zx. Very simple. So in this manner, what we'll do, we can simply take out y minus x as a factor from the second column and z minus x as a factor from the third column to make it more simplified. So we can write it y minus x here into z minus x here. Now we can write 1x cube, 0, 1 and y square plus x square plus yx. Similarly here 0, 1, z square plus x square plus xz, right? So in this manner we have simplified our determinant. Now further we can apply the operation here. How? Simply we can apply our operation on column 2 or column 3. So let's apply again operation on column 2. Let us say column 2 can be written as C2 minus C3 here. So what we'll get here? Y minus x into z minus x. Now 1x cube. This will be 0. Then again 1 minus 1, 0. Now here we can cancel out if we are getting some common term like x square is getting cancelled. So we'll get y square plus xy minus z square minus xz. So now we can write it like this way: z square plus x square plus xz. So what we have to prove here, let's check again. So here we need to prove if x plus y plus z is equal to 0, then we have to show that this determinant is 0 here. So let's do further simplification here. Here we will get y minus x into z minus x. Now we can simply expand this determinant with respect to this column, this row, sorry, with respect to this row we can expand this. So what we'll get? 1 into this gone, 0, 1, y square plus xy minus z square minus xz, and here we will be getting z square plus x square plus xz, right? Now if we see, this part is 0, minus of this one only, into 1 we will get negative of y square minus xy plus z square and plus xz here. Now what we can do here, if we can further factorize it, let's check it out. In the first two terms we are getting y as a common factor here. So here we are getting y as a common factor, or we can simply take out minus y, so that we will get y plus x here. Here we are taking common z, we are getting x plus z here. Now we can see that we are not getting any factor common here. We can use different, or we can pair different terms here. So let's erase it. This part we can erase. So let's pair other part here. Now we can pair y square and z square here. Z square minus y square we can pair, and here we can pair plus xz minus xy, so that we will get some other factor. So here we will get z minus y into y plus z. Here we will take x common, we will be getting z minus y. Now we can see that we are getting z minus y common in both the factors. Here we are getting x plus z plus y here. Very simple. And what it states here now in the question, it states that x plus y plus z, x plus y plus z, it is given that x plus y plus z is equal to 0. That means this entire value, we can say this entire value is 0, because we are getting 0 here. 0 into 0 into this part as well will become 0 here. Hence we can say that this is equal to 0, and hence proved here. So what you have to do, you have to check which pair will give you the answer here. That is more important, because we were not able to factorize in our previous step. That's why we use pairing of different factors here. So I hope this question is clear. Now let's move towards the next question of ISC Board 2025. So students, this is the question number 8 part 1, which was asked in the ISC Board 2025, and I'll tell you how to tackle this question very easily. See, whenever you see the degree of the numerator and the denominator which is in the trigo function, what you have to do, you can simply make the numerator first like the denominator. How? Let's understand. We require 3 with cos x here. So what we'll do, we will simply multiply divided by 3 first. So it will become like this, 3 cos x upon 3 cos x minus 5 dx. Very simple. So this is our first step. Now after that, what we require, basically we require minus 5 here, so we can do plus minus 5. Very simple. 3 cos x minus 5 and plus 5 here. So in the denominator it is same. Now what we'll do, we will simply split it into 2 different parts here. How? Let's see. 1 by 3, first part will become as it is. See, 3 cos x minus 5 upon 3 cos x minus 5, and the another part is nothing but 5 by 3 into integration of 1 upon 3 cos x minus 5 dx. So now we can easily see that the first part will cancel out and it will give you 1 here only. So the integration of 1 is x, so it will become 1 by 3x. So first part is solved here. Now we will focus on the second part, how to tackle it. See, whenever in such a scenario, when there is a trigo function here in the denominator with a degree 1, what we can do here, this is simply this part, a sin x plus b cos x plus c. In such a scenario, whether a is 0 or b is 0, and we have a function like a sin x plus c or like b cos x plus c or a sin x minus c or b cos x minus c, here we are getting this form, which is b cos x minus c. So what we'll do here, we will simply convert this into a half angle formula in terms of tan theta. So what we'll do here, we will simplify the denominator here like this way. So cos 2 theta is nothing but 1 minus tan square theta upon 1 plus tan square theta. So it will give us half angle here, 1 minus tan square x by 2 upon 1 plus tan square x by 2 minus 5. Very simple. So this is the very simple method how to solve these questions when the degree in the denominator part of a trig function is 1 only. So let's move forward. This part is already solved. We are solving the second part. Here we can simply take the LCM, and this will become minus 5 minus tan square x by 2, and this will go in the numerator part. So we'll get the numerator like this, 1 plus tan square x by 2 upon 3 minus 3 tan square x by 2 minus 5 tan square x by 2 here. So what we have done, basically we have simplified the denominator part, and the LCM part of the denominator, that is 1 plus tan square x by 2, will come to the numerator. Now if something is cancelled out, we can simplify these terms here. So what we'll get, 5 by 3, and we can write it this way, 1 plus tan square x by 2 is nothing but what, sec square x by 2 upon 3 minus 5. We can write it this way, 3 minus 5 is nothing but minus 2 here, and this part is minus 3 tan square and minus 5 is minus 8 tan square x by 2 here into dx. So the advantage of using this half angle formula is that if we now substitute tan x by 2 as t, we will be getting the derivative in the numerator here. So let's do this way. Let's put tan x by 2 equals to t, so that we will be getting sec square x by 2 into x by 2 derivative is half is equal to dt by dx. Very simple. So our question will become what? Our question will become, let's make some space here. Our question will become like this way, 5 by 3 into 2 integration of dt upon minus 2 minus 8 t square. Very simple here. Now what we can do, we can simply take out 2 as a common factor, so that we can cancel out this 2, and we will get our question like this way, minus 5 by 3 integration of, we have taken the minus common, so that we can write it this way, dt upon 4 t square plus 1 here. Very simple. Now we have simplified our integral, and now we can take out 4 common here from the denominator, so that our question will become like this way, 4 3s are 12, and dt upon t square plus 1 by 2, we can write it this way, because we are getting 1 by 4 here, 1 by 4 will be 1 by 2 whole square here. Very simple. Now we have to memorize the formula of tan inverse t. Basically integration of 1 upon 1 plus x square is nothing but tan inverse x here. So here we are getting 1 upon x square plus a square is nothing but 1 upon a tan inverse x by a here. So we will be getting minus 5 by 12 into 1 upon a into tan inverse x by a this way, and plus c here. So first part we have already simplified. This is basically the second part. So here we can simply substitute the value of t, and we have substituted tan x by 2 is equal to t. Now we can simply cancel this out. Minus 5 by 6, 10 inverse 10x by 2 upon half and plus c here. So what we have done, let's check it out. Here we got the first part as x by 3 and this was our second part. So after simplifying the second part by using half angle formula in terms of cos, so we are getting this answer here, and our final answer is this one, minus 5 by 6 tan inverse 10x by 2 upon half plus c here. So students, that was the most simplified form and I try to explain you in the most easiest manner. Now let's move forward towards the second part of question number 8. So students, this is the question number 8 part 2 here. We are having integration of log x whole square. Whenever you get a logarithmic function or an inverse trigo function to integrate, then you have to always remember that you have to use 1 here, because you can't integrate directly the logarithmic function as well as the inverse trigo function. Now what we'll do here, we need to use isolate here. So what we have to do, we will be considering, that is integration of log x whole square, that is the first function into second function here, which implies first into integration of second minus integration of derivative of first into integration of second function here. So we need to integrate this way only by using the isolate method here. Now let's start. So here we have to consider the first function as log x whole square, because we are having the derivative available of this one. So log x whole square into integration of 1, we have substituted 1 here, which will give you x, minus integration of derivative of first, that is log x whole square, the derivative is 2 into log x into 1 by x into integration of 1 is again x here. So this is going to get cancelled here into dx. So our integral will become log x whole square into x minus integration of 2 log x here. So again we are getting the log x function, so we have to continue it with the help of isolate method here. So what we are going to do, we are going to further use the isolate method here. So let's use the isolate method here. Log x whole square into x minus 2 into, again we have to use log x as the first function, into integration of 1 dx minus integration of this function, or we can do that we can take this 2 as a common factor, because otherwise it is going to create some trouble here. So what we have to do, we have to take this 2 common. Now let's start again. Minus integration of derivative of log x, which is 1 by x, into integration of 1, which is x again, into dx. So it is going to get cancelled. Now our function is completely done. Now what we will get here, log x whole square into x minus 2 into log x into x is x log x minus integration of 1 is x here and plus c. So what we will get here, we will get log x whole square into x minus 2x log x and plus 2x plus c here. So this will be our final answer here. So I think the concept is clear now. Whenever you get a logarithmic function or an inverse trigo function, you have to use 1 so that you can use the log or integral function as the first function. So in this manner we were able to simplify or integrate our log x whole square function. So this is our final answer, what we are getting, that is log x whole square into x minus 2x log x plus 2x plus c. So I hope the question number 8 part 2 is clear now. Now let's move towards the question number 9. of ISC Board 2025. So students, this is the question number 9 first part. Here it is stating that if x equals to this, then we have to show that 1 plus x square into y double dash, that is d square y by dx square plus 2x minus a into y dash is equal to 0. So let's see how we can proceed here. Now here this part is a little tricky here. So what you can do here, you can simply take this tan here in our first step, so that it will make things more clear to you. Now let's write it this way, tan inverse x. So our question will become tan inverse x equal to 1 by a log y. Now we will take a here, so our question will become a tan inverse x equals to log y. Very simple. So now we can see that our question is more simpler what we have in the main question here. Now let's move forward. Now differentiating with respect to x, we will be getting a into 1 upon 1 plus x square equals to, the derivative of log y is nothing but 1 upon y into y dash. So this is our derivative. Now let's make some space here so that we can elaborate it more clearly. Now what we can do, we can simply cross multiply this and we will be getting a into y, which is ay equals to y dash into 1 plus x square. I think I am clear here. We have simply cross multiply our question here, what we have done here. So now differentiating again, we are going to get a into y dash is equal to y dash into derivative of this is nothing but 2x plus 1 plus x square into y double dash. In such a questions where we need to show that or prove that, you have to check whether we are going in the right direction or not. Now we can easily see that we require this one, y double dash into 1 plus x square, and here we are getting our answer here. That means we are going in the right direction here. Now we can simply proceed further and further simplify it. So how we are going to get our answer? Now we can take this part here or this part towards the RHS. We will be getting y dash into 2x minus a into y dash plus 1 plus x square into y double dash equals to 0 here. Now combining these two parts, we will be getting y dash 2x minus a plus 1 plus x square into y double dash equals to 0. So let's check whether we are getting our answer or not. We will check here. We have to prove 1 plus x square into y double dash, v plus x square into y double dash, 2x minus a into y dash, 2x minus a into y dash. So hence we have proven what was required in the question here. So this is our final answer. I hope this concept is also clear. And now let's move towards the second part of question number 9. So students, this is the second part of question number 9. Here we are having one graph here, and the graph of fx is this one. Find the slope. First part is find the slope of the above graph. So this is the very easy question. Basically find the slope of the above graph means if we find f dash x, then we will be getting the slope here. So simply if we will derivate this fx, or we can say f dash x equals to minus 3x square plus 27. So this is our slope here of the first part, and we were able to get our answer. Now what it states in the second part, that is part B here. So find the coordinates of the turning points A and B. How we are going to get those turning points? We have to find the critical points here. How? First we have to derivate, and we have already derivated this f dash x equal to minus 3x square plus 27. Now what we'll do, we will simply find the critical points here. So how we are going to get the critical points here? Let's make some space here. Now let's put it equal to 0. So minus 3x square plus 27 equal to 0. So this implies what? X square is equal to 27 by 3, which is 9, and x equal to plus minus 3. So we are getting two critical points, which is plus minus 3 here. So the value of x is plus minus 3 here. Now we can easily find the coordinate, y coordinate as well. How? let's substitute minus 3 in the given equation. And what is the given equation here? We have the given equation this way, that is minus x cube plus 27x minus 2. This is equal to y basically. Now if we put minus 3 here, we will be getting minus 3 whole cube plus 27 into minus 3 and minus 2. So here we are going to get minus 27, that is plus 27, and here we are going to get minus 81 minus 2. So here we are going to get 83 minus 27 is 756 minus 56 here. So we are going to get y coordinate is minus 56. Hence we can say that when x is negative, so y is also negative. So in the third quadrant here, x and y both are negative. So minus a is minus 3 and b is minus 56. Similarly, if we put x equals to 3, then we are going to get the value of y here. So let's substitute that as well. So here we need to substitute like 3. So 3 cube plus 27 into 3 minus 2, that is 3 9 27 plus 81 minus 2, that is 718 8 to 10, and this is 106. So our coordinates are 3, 106, right? And another coordinate is minus 3 and minus 56 here. Hence we were able to find the values a comma b and c comma d here. C comma d we have already find because this is the first quadrant and we are getting the positive values here of x and y. So we got our values here. Very simple. Now in our third part, evaluate f double dash minus 2, f0 and f dash 3. This is very easy part. The most easiest part of this question is part C here. Now what we have to do, we have to simply f double dash 2 we need to find out, and f dash x is this. So f double dash x equals to minus 6x. So this is f double dash x. Now if we substitute 2 here, we will be getting f double dash minus 2. So f double dash minus 2 is equal to minus 6 into minus 2, which is plus 12 here. Another part is f of 0. We need to find f of 0 here. So we need not to find f dash and nothing like that. So we need to directly substitute this in our function, which is x cube plus 27x minus 2 here. So x cube is nothing but what? 0. So 0 plus 0 or minus 2. So we will be getting f of 0 is equal to minus 2, and we need to find f dash 3. So f dash 3 is, we need to substitute 3 here in the function. So 3 cube plus 27 into 3 is 81 minus 2. So this is 27 plus 81 minus 2, and we will be getting what? I think we have find it out before as well. 27 plus 81 minus 2, yes. So this is 106 basically. So 106. So this is our answer, that is f dash 3 we got as 106 here. So I hope this concept and this question is also clear, and we were able to find out the coordinates a comma b as well as c comma d as per the requirement of this question. So that was all in this particular video, and we will be solving other questions in our next video. Till then, goodbye, and if you like the video, then please share and subscribe our channel. Thanks a lot.